If you were to ask me about my credentials, I would say that I don't know anything about trash and I just throw it away. But what I do know is that Earth's orbit is turning into a junkyard at an alarming rate. Space debris is kind of out there, man. It currently poses a huge threat to space exploration and even to life on Earth. How could that be, scientific wizzy? Space isn't Earth, Earth isn't space. So how can debris that isn't space affect us on Earth? I don't... The junk we have left in orbit through our decades of space exploration ranges from tiny little flecks of paint to whole satellites that are no longer functional. My goal today is to uncover how this mess even came to be, the dangers it brings, and some ambitious ways to clean it up. So, back in October 4th, 1957, the Sputnik was launched, and it sparked the whole space race thing. In the following decades, space became the ultimate playground for governments to test out their cool rockets that could explore the void we know out there. By the 1980s, over 5,000 satellites had been launched, but no one ever just thought to stop and think about what could happen to this metal when it was no longer even useful in orbit. Every satellite launch since the Sputnik added leftover rocket stages, bolts, tools, and even the occasional astronaut glove. All of this is pointless. Space debris is just orbiting the planet for nothing. It's like a little ring, like Saturn, except it's not natural and it's just trash. NASA estimates that there are over 100 million pieces of debris smaller than a centimeter zipping through orbit right now. The space industry is now bigger than ever, with private companies like SpaceX and OneWeb launching thousands of satellites for global internet coverage. They're creating what's called mega constellations, which are these vast networks of satellites that are in low Earth orbit. By 2030, we could see up to 100,000 active satellites in orbit. While these man-made constellations promise faster internet, they also increase the risk of collisions, which make, you guessed it, even more space debris. The result? A dangerously crowded orbital highway that blocks our path to the stars. And it only takes one accident to cause a catastrophic chain reaction. In 1978, NASA scientist Donald Kessler predicted what is now known as the Kessler syndrome.
Okay, now we're getting to the interesting thing, why your name is associated with a syndrome. What happens when these objects collide, and what's the risk there?
Well, they end up producing an awful lot of small fragments. And those fragments then, the larger of those large fragments, then go on to hit something else and cause it to break up, and you get essentially a chain reaction of events where you get an increasing frequency of things breaking up as a result of collision.
Eventually, low Earth orbit becomes so incredibly cluttered and polluted that space is no longer serviceable. Even today, the International Space Station has to maneuver several times a year to avoid these collisions. And space debris isn't just an issue for the astronauts up there. It affects life here on Earth too. You see where I'm getting here? You see my point? Man, it doesn't affect Earth. Yes, it does. Satellites are the literal backbone of modern life. GPS, weather forecasts, internet, and even financial transactions rely on them. If we don't have satellites, then you can't trade your Bitcoin, guys. There's also the dangers of debris re-entry. While most burn up in the atmosphere, larger objects can survive and will crash into populated areas. In 1979, in fact, pieces of NASA's Skylab that disintegrated in orbit fell onto Australia. Fortunately, the space community is aware well of this problem and actively working on solutions. But cleaning up space is kind of a big deal and definitely not an easy task. One of the most promising methods is active debris removal. For example, Japan's JAXA has tested a satellite that deploys a net to capture larger debris. Once caught, the debris is dragged into Earth's atmosphere where it burns up during re-entry. Other projects, like the European Space Agency's laser systems, aim to zap smaller debris, altering their orbit so they fall back to Earth. These are all super cool, sci-fi sounding incredible ideas, but they come with many challenges. Cost-wise, technical limitations, and international cooperation. After all, space is a global and expensive common area, but who wants to be responsible for cleaning it all up? Prevention is just as important as cleanup, though. New satellites are being designed with self-destruct mechanisms to deorbit themselves at the end of their projected lives. There's also space agencies that are improving tracking systems to prevent collisions in the first place. But regulation is key at the end of the day. So much so that organizations like the United Nations are pushing for stricter guidelines on satellite launches and debris mitigation. Sadly, in the end, space debris is just a reflection of how humanity interacts with its environment. History repeats itself, and just as we've polluted the oceans and the atmosphere and the forests, we've also left our mark in space now. But it's not too late to change. By investing in cleanup technologies, enforcing better regulations, and fostering international cooperation, we can ensure that space remains accessible for future generations. All in all, we need to clean up the mess we've made.